Okay, so in this video we're going to do the 7.6 sine and cosine ratios as part of the review for the Ryken Geometry Final. So sine and cosine ratios, that's going to be so and ca. So if I want to find the value of angle x using the sine ratio, here's angle x. So from angle x's perspective using sine, so the sine of x equals opposite, which is the 20, over hypotenuse, which is the 50. So the sine -1 of 20 over 50 will get us angle x. Why is that the case? Because I'm taking the sine to the -1 of both sides, these words cancel, leaving me with angle x, and then I'm going to take the inverse sine of the ratio to get the angle back. So in my graphing calculator I say second sine to the -1 of 20 divided by 50, and I get an angle of 23.6 degrees. So angle x, which is this top angle right here, is 23.6 degrees. Let's now do angle z. So let's change color. And if I want to find the value of angle z using the cosine ratio, then I say the cosine of z, cosine equals adjacent over hypotenuse. So adjacent is the angle or the length next door, 20, and the hypotenuse is always opposite the right angle, so that's 50. Notice we have the exact same ratio, but we have a different trig sign. So now you take the inverse by saying cosine -1 of both sides. That cancels. So angle z will equal cosine -1 of 20 over 50. In my calculator, I am going to put cosine -1 of 20 divided by 50, and I get an angle for z of 66.4 degrees. So let me just clean up some of this in here. We will put the angle of 66.4 right there. Okay, so it's going right here. These two angles, the 66.4 and the 23.6, need to sum to 90. And if you check that with your calculator, 23.6 plus 66.4, I get 90, and I know that I am correct. Those two angles must be complements. Okay, so look back at our previous work. Make sure that you understand that I'm using inverse trig with certain ratios to get the missing angles. Let's move on to solving right triangles in 7.7 on the next slide. Okay, they're going to ask us to solve the right triangle for all the missing sides and all the missing angles. So I know I have a missing angle right here, only one missing angle, and I have a missing side here and a missing side there. So to get the missing angle, missing angle, I'm going to label my triangle so I can speak about things more clearly. So let's call this A, B, and we'll put the C at the right angle. So I want missing angle A. So to get missing angle A, I can take 90 and subtract away the 38 because I know angle A and angle B must be complements. So 90 minus 38 gives me a missing angle of 52 degrees. So this angle right here is 52 degrees, and that's the quickest way to get your missing angle because you have two of the three angles in this triangle. Okay, so that's the first piece that's missing. Now I need to get some sides. So let me look at angle B. From angle B's perspective, this is opposite, and this is adjacent. So what does that remind me of? That reminds me of tan. So tan is opposite over adjacent. So therefore, I can say that the tan of 38 degrees equals, why don't we make this little baby b, since it's opposite big angle B. So little baby b over adjacent, which was 67. Do your cross products, and the cross products, if it helps you to put this over 1, that's totally fine. So the first set of cross products is 67 times the tan of 38, and that is going to equal angle B. This is a one-step problem. So 67 times the tan, straight up tan, because you're looking for a missing side, not a missing angle, that's going to equal a value of, a side length for B of 52.3. So on this orange line, I'm going to put 52.3. Okay, let's change colors. And why don't we get rid of this confusion on the bottom here. Okay, so that's pretty much gone. There we go. Okay, so let's find the missing hypotenuse. Now we have some options here. I think by far the easiest option probably is just to do Pythagorean Theorem. So Pythagorean Theorem tells me a squared plus b squared equals c squared. And these are angles. These are not angles, these are side lengths. So I'm going to write that differently. I'm going to write them in capital letters. So a squared plus b squared equals, no, I'm not going to do that, c squared. I'm not going to do that. I'm taking that back. Okay, so because they are side lengths, the side opposite angle A is the A side. So that's a squared. The side opposite angle B is the b squared. And the side opposite angle C is the hypotenuse, which is what I'm looking for, which is the c squared. So a squared, do I have a value for A? And I do, and that was the given value of 67. So 67 squared plus b squared is 52.3. Square that. That has to equal c squared. Okay, before you reach for your graphing calculator, write this step down. Take the square root of both sides. So in your graphing calculator, you put second square root of 67 squared plus 52.3 squared, and you say equals, and that's going to give me my C. C equals 85. On this line, I'm going to put 85, and now you have completely solved for this triangle. Let's go ahead, we'll do problem 40, which will be the last problem in this section, and also the last problem on the review. Okay, so in question 40, I am missing both angles. So I don't have an angle here, I don't have an angle here, and I don't have a side there. So we're going to go ahead and label our triangle the same way I labeled number 39, okay? All right, so I can't do subtraction to get my angle since I'm missing two angles. I could do the Pythagorean Theorem to get a missing side since I am only missing one side. So let's go ahead and do that. So what I have, I know my formula is a squared, because the a side is across from angle A, plus b squared, another leg, equals c squared. So what do I have? I have a squared, that's going to be 17 squared. I don't have b squared, but I do have c squared. So b squared is going to be 40 squared minus 17 squared, because I moved this by doing subtraction. Okay, so don't grab your calculator yet. Write down this step. Your side length B is going to equal the square root of 40 squared minus 17 squared. Now take your calculator. Square root of 40 squared minus 17 squared, enter, equals a length of 36.2. Remember, everything is rounded to the nearest tenth. So on this red line, I'm going to put 36.2. Okay? Now we need to get an angle. Once I get one angle, I'm going to use subtraction to get the second angle. So let's say that I really want to use, I really want to use sine. So from angle A's perspective, I can say the sine of A. Do I have enough information? Yes, I do. The sine of A equals opposite, which is 17, over hypotenuse, which is 40. How do I know that? Because I know that sine is so of the SOHCAHTOA phrase. So I don't want the ratio, I want the angle back. So take the sine negative 1 of both sides. That cancels. My angle A will equal sine negative 1 of the fraction 17 over 40. Put that in your graphing calculator. Second, sine negative 1. I'm getting an angle back. I always use inverse trig. Equals 25.2. So angle A equals 25.2 degrees. Okay, so wherever I have angle A, I'm going to put 25.2. How will I get angle B? Well, I know that angle A and angle B have to be complements. So I'm going to say 90 minus 25.2 will equal angle B. So 90 minus 25.2, boom. Angle B is 64.8 degrees. And every value for this triangle is now attained. Okay, we have the two angles and we have the missing side. So we are all set to go, and that completes this review.